Good day, students. In this clip, we're going to go over how to show that the roots determined using the quadratic formula are correct using the factor theorem, okay? All right, so the instructions are show that the roots determined by the quadratic formula are roots of a quadratic equation in standard form using the factor theorem, okay? So basically, a quick summary of the theorem, of the factor theorem, is that if uh, r is a root of a function of a polynomial function of f of x, then by the factor theorem, f of r is equal to 0. So if you substitute r for x in that function, if it is a root, you're going to end up with 0. This is a extension of the remainder theorem, because if a value is a root of a function, when you divide it by that function, you're not going to get any remainder. Okay, so that's why it's given a special name called factor theorem. So the roots you determine using the quadratic formula are roots of the polynomial, so when you plug them into the function, you should not have any remainder. Okay, so this is the factor theorem. So what are we going to show in this proof? What we're going to show, let me show you the objective. We must show that um, if the two roots, you have two roots when you use the quadratic formula. What are the two roots that you get? Let's write down them in separate form. Okay, let's show that if r1, the first root, equals negative b plus the square root of b squared minus 4ac over 2a. If r1 and, you know, there are two roots, right? r2 equals negative b. You know it's plus or minus, so that's a positive plus component, and then minus the square root of b squared minus 4ac over 2a. Now, if these two are roots of a quadratic function, written a quadratic function in standard form, written in function form, are roots of f of x equals ax squared plus bx plus c. This is the general form of a standard form of the quadratic equation, but I wrote it in function form. So if these two are roots of this function, then f of r1 is going to be equal to f of r2. You know what they're going to be? They're going to be equal to 0. Both of them have to be 0. Okay? So what I'm going to do is I'm going to split this proof into two parts. I'll do the first part. I'll show that f of r1 is equal to 0. And I'd like you to do the second part. Okay? If you can show that both of them equal 0, then you can conclude, in fact, that the roots determined using the quadratic formula are correct. Okay? All right, so I'm going to do the first part. I'm going to proof. I'm going to show, this is my goal here. I'm going to show that f of r1 is equal to 0. And what's your assignment? Your assignment is to show that f of r2 is also equal to 0. Then we can conclude that we're done. Okay? All right, so how am I going to do this? Well, let's start by writing down what the function is. What is the function? The function f of x is the quadratic equation written in function form, the standard form of a quadratic equation written in function form. F of x equals ax squared plus bx plus c. Now I'm going to show that f of r1 is equal to 0. Okay? So f of x is that, and r1 is the first root negative b plus the square root of b squared minus 4ac. When you're doing your portion of this proof, you're going to use negative here, okay? Over 2a. All right, so what on earth is f of r1 going to be? F of r1 is basically what you get when you replace all the x's with this root right here, okay? So a, instead of x squared, we're going to have negative b plus the square root of b squared minus 4ac over 2a. Okay, now that's my x. X is being squared here, so square plus b times x. But what is x? X is going to be r1. So we're going to plug in negative b plus the square root of b squared minus 4ac again. That over 2a. Okay, plus c. Okay, so if I can simplify this and end up with 0, then I'm done. And then I can move to the second part that you're going to help me figure out. Okay, it's the same procedure, just a slight alteration in the signs will enable you to arrive at the same result. All right, so let's work this out. Just use some algebraic rules. Here we have squares, so we're going to multiply this expression by itself. So negative b plus the square root of b squared minus 4ac over 2a. That times itself, negative b plus the square root of b squared minus 4ac over 2a. Plus, now in this case, we're going to distribute this b to this entire expression. Imagine that's b over 1, okay? So if I distribute it, I'm going to have negative b squared plus b root b squared minus 4ac over 2a plus c, okay? All right, let's focus our attention on simplifying this piece right here. We'll leave this untouched, and then we're going to use it later, okay? So first thing we're going to do is FOIL this out. First outer, inner, last, okay? So a times first, negative b times negative b is b squared. Outer, negative b times this expression is negative b root b squared minus 4ac. So first outer, and then inner is also going to be negative b root b squared minus 4ac. And then last will be those two plus b squared minus 4ac. The square root of b squared minus 4ac squared, right? So if you multiply that b squared minus 4ac times itself, so you're going to square it like that. Okay, and that entire expression divided by what? What are we going to have in the bottom? Well, you're going to multiply 2a times 2a. 2a times 2a is 4a squared. Okay? And then that, see this, I'm going to just drop this down. We're not changing it, doing anything with it. Let me just put it here. Negative b squared plus b root b squared minus 4ac over 2a. And then also bring down the c. Okay, now let's simplify this further. We have a times, now b squared. These two are like terms, right? So we can write it as b squared minus 2b root b squared minus 4ac. These two quantities have the same sign, so we just add and keep the sign. And then over here, the square root will cancel out. Okay, this cancels with that. So you're going to be left with plus b squared minus 4ac. Okay, this entire expression divided by 4a squared. And I'm going to leave this alone. I'm going to keep simplifying these other ones, okay? That's what matters right now. All right, so let's see. Simplify this a little bit more. We're going to have, oh wait, no, here we can reduce this a with that right there, right? So a goes here 1, and that cancels out, okay? On the top, b squared and b squared, you can add it up. You get 2b squared, right? So you have 2b squared minus 2b root b squared minus 4ac minus 4ac. That whole entire expression over 4a. I mean, oh yes, over 4a. Okay. And then you can note that I can factor out 2 from the numerator. Okay. This expression right here, let me just bring it down. It's not changing. It's just there. It's been. We don't need it yet. We're gonna need it later. Let me just bring it down so we don't forget it. B squared minus 4ac over 2a plus c. Okay. All right, and then on the numerator, I can factor out a 2. So I take out a 2, and I'll be left with b squared minus b root b squared minus 4ac. And then if I factor out a 2 from here, I'm just going to be left with 2ac. Okay? And that will be divided by 4a. All right, what can we do here again? We can divide it. See, this 2 goes into that 4. 2 goes here 1. 2 goes here 2. So it's now going to become b squared minus b root b squared minus 4ac minus 2ac, that whole expression over 2a, okay, minus, plus negative b plus b root b squared minus 4ac over 2a plus c. Okay, now let's see. Oh, no, notice that these two terms have the same denominator, so we can combine them and just evaluate the numerators, right? So we can have b squared minus b root b squared minus 4ac minus 2ac minus b plus b root b squared minus 4ac, right? And then that entire expression divided by 2a. And then plus c over here. Okay, let's move along. Now let's see, what can we do here? Let's see. All right, we can simplify, but before we simplify, let me just make a real quick addition here. You notice this is a b square, so I need to add a square here and a square there. Excellent. Okay. All right, so what happens here, you notice that we have a couple of opposites happening. This b squared and this b squared are opposites, so they add up to 0. Negative b root b squared minus 4ac is the opposite of b root b squared minus 4ac, so they add up to 0. So what we end up with is negative 2ac over 2a plus c. All right, these two divide out, so you end up with negative c plus c, and your final answer is 0. Okay, so what does this mean? This clearly shows, that r1, which is equal to negative b plus square root of b squared minus 4ac over 2a is a root of the polynomial function f of x equals ax squared plus bx plus c. Okay, by the factor theorem. Now we're not done yet. We have to show that the other root is also a valid root. Okay, so now this is your part. Now you're going to show that f of r2 is equal to 0. So if you can do that, that will show, then we can conclude that the quadratic formula is in fact correct. Okay, so try it out and post the comments concerning if you were successful or not for complications you experienced while executing these steps. Let me know how it is, and then we can go from there. Thanks so much for taking the time to watch this presentation. Feel free to subscribe to my channel by clicking here so you can get updates to other cool clips such as this. And also post a comment to let me know how you were able to complete the proof, or to let me know what you think about this presentation in general. More clips can be found on mybestserve.com. Thanks again for watching, and have a wonderful day.